Okay, today I'm going to talk about section 6.6, the inverse trigonometric functions. This is like outline. Definitions and graphs of the inverse trigonometric functions. I'm going to talk about properties of the inverse trigonometric functions. I'm going to talk about derivatives of the inverse trigonometric functions. First one, integrals for the inverse trigonometric functions. This is the definition. The blue one is y equals sine of x. My question is, does the inverse function exist? You can draw horizontal line. The horizontal line is like the red one. The horizontal line intersects the graph of f. X equals sine of x more than once. So what does it mean? So like this. We have this intersection point. So what does it mean? We have infinitely many intersection points. Infinitely many intersection points. So what does it mean? It is not one-to-one inverse function, does not exist. How can you find the inverse function of f of x equals sine of x? Restrict the domain. We can restrict domain like this. Here, I can restrict the domain from here to here. So this is negative pi over 2 to pi over 2. So we have inverse function, the restricted domain. So what does it mean? So like this. This function is y equals sine of x. X is between minus pi over 2 and pi over 2. This is domain. The range is minus 1 to 1. Reflect the graph of f sine of x about y equals x. We have the graph of the inverse function of f of x equals sine of x. How can you draw inverse sine of x? So we use this idea. You draw y equals x. You have to reflect the graph of f of x about the gray one, y equals x. So we have this one is the inverse function. So we have it. What's like inverse function? I want to use notation. Inverse sine of x or arc sine of x. What's the domain? X is from minus 1 to 1. Range is minus pi over 2 and 2 pi over 2. So what does it mean? The range of f is going to domain of f. Domain of f is going to range of f. That is the idea. The next, I want to use cancellation equation. Sine of inverse sine of x equals x. For all x in the domain, x is between minus 1 and 1. So we have another cancellation equation. Inverse sine of x equals x for all x in this domain. This is the domain of a sine function. The next, we think about cosine function. The same. Cosine function doesn't have an inverse function because cosine function is not one-to-one. How can you find the inverse function of cosine of x? We use same idea for finding the inverse function of sine of x. The idea is that we restrict the domain. So domain is like this. 0 to pi. Domain is 0 to pi. Range is minus 1 to 1. How can you find the inverse function? Reflect the graph of f about y equals x. We have the graph of the inverse function of f of x equals cosine of x. So how can you find here? You draw y equals x. The next reflect the graph of cosine of x about y equals x. You have to reflect. Just reflect. Like this. Just reflect. So we have this one. Like this. Notation of inverse function is inverse cosine or arc cosine. Domain is minus 1 to 1. Range is 0 to pi. That's right. The same here. Range of f is going to domain of inverse function. The class is over. I just only redo my lecture again because I didn't record. This is the reason. It doesn't matter. You can see my lecture here, and any question, let me know. Not a problem. You can only check depending on your choice. Only stay or leave. It doesn't matter because I only record. Yeah. So here we have range is our inverse function is exactly same to domain. So we have it. So we have cancellation equation. Cosine of inverse cosine of x equals x for all x in minus 1 to 1. Inverse of f of x equals x. Inverse cosine of x equals x for x in the domain of cosine 0 to pi. Okay, this is idea. So next one, we think about inverse function of f of x equals tangent of x. The domain is minus pi to 2 and pi to 2. Range is minus infinity to infinity. How can you find the inverse function? Same idea. Reflect the graph of f of x about y equals x. We have the graph of the inverse function f of x equals tangent of x. How can you find the same things? You can draw y equals x. I can draw y equals x here. You can draw y equals x. This one. This is y equals x. You have to reflect. This vertical asymptote is going to horizontal asymptote here. Horizontal asymptote. This is pi over 2. So also another horizontal asymptote, the negative pi over 2. The next, reflect the graph of f of x about y equals x. We have this graph. Graph is like this. So we have this one. Inverse of f of x is this notation. Inverse tangent of x, arc tangent of x, domain is minus infinity to infinity, range is minus pi over 2 to pi over 2. What's the limit value? Inverse tangent of x approaches this value here. X value approaches negative pi, negative infinity here. X value approaches negative infinity. What is inverse tangent of x? Inverse tangent of x approach to this horizontal asymptote minus pi over 2. So this is answer. Similarly, limit inverse tangent of x as x value approaches infinity is pi over 2 because x approaches infinity, x value approaches positive infinity. What is the inverse tangent of x? Inverse tangent of x approach to pi over 2. So we have this result. We have a cancellation equation. Inverse tangent of x equals x for all x values. So another cancellation equation. Inverse tangent of x equals x for all x in the domain of tangent minus pi over 2 to pi over 2. The next one, the remaining inverse trig functions. So I don't explain them more. You can define inverse cosecant, inverse secant, inverse cotangent. So this is like possible. So next, evaluate limit arc tangent of ln over 5 minus x as x value approaches 5 from the left. How can you solve this problem? I can show to you. X value approaches 5 from the left. 5 minus x approaches to 0 from the right. What is ln function? You can draw the graph of ln. The graph of ln is like this. This is ln of x. The inside one approaches to 0 from the right. What is ln of x? Approaches to negative infinity. So this value approaches negative infinity. What is arctangent? You draw graph of arctangent. The graph of arctangent is like this. One horizontal asymptote, pi over 2. Another one, negative pi over 2. Here, inside one, approach it to negative infinity. So what is it like inverse tangent of x? This is graph of inverse tangent of x. This is inverse tangent of x graph. Inside one approaches minus infinity. So arctangent approach to this horizontal line, negative pi over 2. Answer is like this. Approach to the negative pi over 2. So final answer is negative pi over 2. That's it. This is answer. Negative pi over 2. We have this result. We can solve this problem step by step. Next one. Find the exact value of inverse sine of sine pi over 4, inverse sine of sine 5 pi over 4. The first one, inverse sine of x equals x for all x in the domain of sine from minus pi over 2 to pi over 2. So what is the answer? You can apply this cancellation equation. We have it, pi over 4. Because pi over 4 is in the domain. Second one, inverse sine of sine 5 pi over 4 equal to 5 pi over 4. This is wrong because 5 pi over 4 is not in the domain. Not in the domain, doesn't matter. Final, this is not the 5 pi over 4. So, how can you solve this problem? We can use this idea. You need to find another sine function value exactly same to sine 5 pi over 4. So you need to find this one. You can find sine of another angle. You can find another angle. This x is in the domain. X is between negative pi over 2 and pi over 2. So like this. How can you find this x value? This x value is like this one, the negative pi over 4. How can you know that? So we have this one. This one. How can you know this result? I want to use this one. Here we have here. Do you know this one? All students take calculus. What does it mean? All trig functions positive. Only sine function is positive. Only tangent function is positive in third quadrant. Only cosine function is positive in the fourth quadrant. So what happens? Sine function, I can draw more things here. This one. So we have like this. Here, this angle is 0. Angle is pi over 2. Angle is pi. Angle is 3 pi over 2 or minus pi over 2. The same to the negative pi over 2. So like this. So let me see. What is 5 pi over 4? I can write here. 5 pi over 4 is exactly same to pi plus pi over 4. We have it. So pi is this angle. We have more. This one is exactly like this. This is angle is this one. This angle is 5 pi over 4. 5 pi over 4. So let me see. So I can use the previous result. So what does it mean? So like this. What happens? Sine function. Sine function is positive in first quadrant. Second quadrant, positive. Third quadrant, negative. Fourth quadrant, negative. Which one has the same sign? Here, we have angle is third quadrant, negative. This is also same angle in first quadrant. So how can you find the other angle? You have to reflect this graph. You have to reflect this one about y-axis. You have to reflect. We have same sine values. So what's like this angle? This angle is exactly same to pi over 4. So this is also the pi over 4. What's like exact angle? we use clockwise direction, angle is negative pi over 4. So we have it. Pi over 4. This is the idea. The next, you can take inverse sine. What happens? The inverse sine and sine cancelled, minus pi over 4. So because minus pi over 4 is in the domain. This is the idea for solving this kind of problems. The next one. So we think about another one here. Find the exact values of sine of arc tangent of 3 and simplify cosine of inverse cosine of x. What's the like idea? I can solve sine of arc tangent of 3 first. You need to write arc tangent of 3 is unknown value theta. This is exactly same to tangent of theta equal to 3. Do you know this one? Do you remember this one? Here. Inverse of x equals y is equivalent to f of y equals x. We can use this relation. Inverse of f is arctangent. So f is tangent. Only interchange x and y. Interchange x and y. We have tangent theta equals 3. So we have it. The next 3 equals 3 over 1. The next, I can draw a right triangle and put here. So what's it like a tangent theta? Exactly the opposite over adjacent. 3 over 1. The hypotenuse is like unknown y. How can you find y? We can use Pythagorean theorem. Y squared equals 1 squared plus 3 squared. 1 plus 9 is 10. Take square root, y equals root 10. So what's the answer? So far, answer is here. So y is square root of 10. Next, we are going back to original problem. Sine of arctangent of 3. What's that? Arctangent of 3 is here. You plug this arctangent of 3 like theta into here. This whole thing is like theta. So sine theta. What's like sine theta? Sine theta is, what's sine theta? We have opposite over hypotenuse. 3 over square root of 10. That's it. This is the answer. The next problem, same. We don't know inverse sine of x. You can write inverse sine of x equals theta. You can use definition of inverse function. So sine theta equals x. X of 1, draw triangle. Sine theta is opposite over hypotenuse, x of 1. We don't know adjacent, you can write y. How can you find y? You can use Pythagorean theorem. 1 squared equals x squared plus y squared. The next, you subtract x squared from both sides. So we have y squared equals 1 minus x squared. Take square root 1 minus x squared. So what is y? This y value is the square root of 1 minus x squared. The next, we are going back to original problem, cosine of inverse sine. What's like inverse sine? You plug. Inverse sine of x is like theta into here. This is called theta. So we have cosine theta. What's cosine theta? The cosine theta is like this one. Adjacent over hypotenuse. The square root of 1 minus x squared over 1. We have it. So this is answer. This is the whole idea of solving this kind of problem. The next one, we think about derivative of the inverse trigonometric functions. Y equals inverse sine of x. I want to use relation of inverse function and the f of x. We have x equals sine of y. Next, differentiate x equals sine of y with respect to x. We have it. What's like a sine of y prime? We can use this idea. F of g of x, the prime is outer function prime of inner function times inner function prime. The sine function is f, y is g. So what's like the next one? This value is sine prime, outer function prime of inner function y times y prime. Exactly cosine of y times y prime. X prime is just 1, right? So we have this result. Cosine of y times y prime equals 1. The next, divide the both sides by cosine of y. We have this one. Y prime equals 1 over cosine of y. Next, I want to change cosine of y by using sine of y. So we use identity. Sine scalar y plus cosine scalar y equals 1. Subtract sine scalar y from both sides. Sine scalar y is cancelled. Cosine scalar y is 1 minus sine scalar y. Like this. Next, take square root. Cosine of y is the square root of 1 minus sine scalar y or negative square root of 1 minus sine scalar y. How can you find exact answer? Which one is your final? The positive one, one negative one. I want to use this idea here. Y is inverse sine function. Was it like a range of inverse sine? You can check my first slides on today's lecture. So this angle y is between negative pi over 2 and pi over 2. This is exact range of inverse sine. But next, we can check cosine of y is positive or negative. You can check these kind of things. How can you check? That we use it here. Draw quadrant. This is angle 0, also 2 pi. This angle is pi over 2, pi, 3 pi over 2, like this. What's it like a cosine function? Cosine function is positive in first quadrant, negative in second quadrant. Third quadrant has a negative, fourth quadrant has positive one. So let me see. The 3 pi over 2 is exactly same to minus pi over 2. Was it like range of y? Range of y is minus pi over 2 and pi over 2. Exactly positive and positive. This is always a positive. What does it mean? You have to ignore negative, choose positive one. So we have cosine of y is square root of 1 minus sine square of y. We are going to this original one again. Y prime equals 1 minus cosine of y. Here, you can plug this value into here. The next, what is sine of y? Sine of y is x. You plug into x. So we have square root of 1 minus x squared. That's it. This is answer. So you need to memorize these 6 important derivative rules. Inverse sine of x prime is 1 over square root of 1 minus x squared. Inverse cosine of x prime is minus 1 over square root of 1 minus x squared. Inverse tangent of x prime is 1 over 1 plus x squared. Inverse cotangent x prime is minus 1 over 1 plus x squared. Inverse secant of x prime is 1 over x times square root of x squared minus 1. Inverse cosecant x prime is minus 1 over x times square root of x squared minus 1. Differentiate f of x equals arctangent of sine of x. How can you solve this problem? Here, we have to use chain rule. What's it like a chain rule? The chain rule is like this. F of g of x prime is outer function prime of inner function times inner function prime. You can just change it. What's that? This arctangent is exactly function f. Sine of x is function g. What's arctangent? Arctangent is here. So arctangent of x prime is 1 over 1 plus x squared. So this is what? Arctan prime of inner function sine x times sine x prime. What's arctan prime? Here, 1 plus x squared, 1 over 1 plus x squared. You plug sine of x into here. So what's that? 1 over 1 plus sine of x squared times sine x prime. So like this. So we have it. The next one, sine x prime is cosine of x. This is final. The next thing, we think about integrals. What's like integral? Integral is like antiderivative. So we have one derivative. Inverse sine prime is 1 over square root of 1 minus x squared. What is integral? 1 over square root of 1 minus x squared dx. Antiderivative inverse sine of x plus c. Inverse tangent of x prime is 1 over 1 plus x squared. Integral 1 over 1 plus x squared dx is inverse tangent of x plus c. We have these two results. The next one, evaluate integral 1 over a squared plus x squared dx. How can you solve this problem? Here, integral 1 over a squared 1 plus x squared of a squared dx. You can factor out a squared from the denominator. You can change x squared of a squared to the x of a squared and take out 1 over a squared. How can you solve this integral 1 over 1 plus x of a squared dx? How can you solve? So we use u substitution. So u is inner function x of a. What's it like du? The du is x of a prime dx. What's x of a prime? A is constant. Take a constant to 1 of a, just x prime dx. X prime is exactly same to 1 times dx. The final answer is 1 over a dx. So we have like this. The next multiply the both sides by a is right. The multiply the both sides by a is cancelled. Dx is ad. The next we are going back to original problem. You can replace. What's x of a? The x of a is u. You plug u into here. What's like dx? Dx is a du. This is a du. We have it. The next, cross out common factor a. The next, what is integral 1 over 1 plus u squared du? We use this rule. You can replace x by u. X by u. Exactly inverse tangent of u. We have this one. The next, change back. What's like u? X of a. You plug x of a into here. The final answer is 1 over a inverse tangent of x of a plus c. So from this result, you need to memorize these rules. Integral 1 over 1 minus x squared dx is inverse sine of x plus c. Integral 1 over 1 plus x squared dx is inverse tangent of x plus c. Integral 1 over the square root of a squared minus x squared dx is inverse sine of x of a plus c. The one more general form, integral 1 over a squared plus x squared dx is 1 over a times inverse tangent of x of a plus c. You can memorize these 4 rules. This example, the last example, the integral 1 over the square root of 9 minus 4x squared dx. How can you solve? You can use this idea. You can change this 4x squared, this one to the 2x squared. The next, you have to use u substitution. U is inner function 2x. The du is like this. 2x prime dx. 2x prime is 2 dx. So we have it. The next, divided by 2. So we have 1/2 du equals dx. So like this. The next, you need to change. Here, 2x is u. dx is 1 over 2 du. You can change like this. Next, take out 1 over 2. You change 9 to the 3 square. What is integral 1 over 3 square minus u square du? I want to use this rule. A is 3. X is u. So u, a is 3. Exactly inverse sine of u over 3 plus c. Do you have to keep coefficient 1 over 2? Integral is inverse sine of u over 3. The next, change back. This u is exactly 2x. So that's it. This is like today lecture. Okay, thank you for watching my video. So that's it.